Hello, welcome everyone to the post-contest discussion of Codeforces round 891. Vijay will explain question A. Vijay, you can start.
Okay, so I think the screen is visible. So let's start with A. In question number A, we are given an array of n integers, and we just need to determine whether it is possible to color the elements into different colors such that the sum of both the parts should have the same parity. So when I say same parity, it means either both of them should be either even or odd. So it's very clear. Like if say in the given example, we color the array with blue and red. So if the blue part and red part should have the same parity, it means either both the sum of blue color and red should be even, or the sum of blue and the sum of red both should be odd. So in either case, like the sum of entire array should be even, because odd plus odd and even plus even both will give us the sum of even. In that case, we can simply do the find the sum of the entire array and say that if the sum of array is even, we conclude that yes, it is possible to color the array in two different colors, and if the sum is odd, it's not possible. So the situation is very simple, and the code is we simply find the sum of the array and check whether it is odd or even. If it is even, we conclude yes, it is possible. I hope it's clear.
Yes, we are.
Sounds all right. Sounds all right. Sound. Okay. Okay. B question में हमें दिया है. We are given a number x that is 2 into 10 to the 5 long. Like you cannot fit it in 18-bit integer or 18, 20, 64-bit integer. Uh, it it will be like 2 into 10 to the 5 digits. There are 2 into 10 to the 5 digits. Okay. So what happens like उससे तो पता इतना तो पता चल गया कि हमें स्ट्रिंग में इनपुट लेना पड़ेगा, because नंबर में इनपुट नहीं ले सकते, because numbers only support 64-bit integer, that is 1 2 into sorry 10 to the power 18. Okay, this is 10 to the power 5. It will not will be supported in int, so we have to input it as a string. Okay. Okay, then let's go to the next part of the statement. We have to choose a positive integer k and round x to the kth digit. Okay, let's see this example. Okay, if we choose this 6, round up, you know the basic rules of rounding up. If it is greater than equal to 5, we have to round it up to 0 and add 1 to the its previous digit. Okay, this 8. Okay, that's copy this. Like if I round up this till sixth, like second digit from right, because rounding up happens from the right only, so it will be like 419,419,900. Okay, it is like that. And also what it mentioned like here is someone like after rounding up, all the digits which are position are less than k will be replaced with zeros. Let's see for this example only. If I round up till this position, like 419, I'll round up this one. So 419 will, sorry, 420. And what you may think it will be like 860. You can write this 860, but क्वेश्चन में मेंशन है कि राउंडिंग अप करने के बाद तुम इसको लाइक 860 नहीं लिख सकते, इसको लिखना पड़ेगा 000। अब मतलब एक इंडेक्स पे, मतलब जिस इंडेक्स पे तुम ये करोगे राउंड अप करोगे उसके पहले वाले सब इंडेक्सेस 0 होंगे। इट्स लाइक अगर इस पे यहाँ तक राउंड अप किया देन दिस विल बी 42000 एंड लेट्स सी 419। If I round up this till this 8 till the 8 one, it will like what we'll get sorry we'll get we have to round this out 0. Okay, 460, then 1 will be carried till here, then that will be also 0 again. It will be 42000. Again what happens, okay, these are the basic rules. We have to like round up till an index, and it all of the indexes after it will become 0 only. Okay, this question is based on only implementation. How will implement depends on how will implement it. Okay, so let's look at the code. Okay, it is a messy code. What happened? I reversed the string. Why? Because rounding up happens from the right side, and it will be like easier for me to like access the things from the right side only. Like I can access 319. I can do it from like 319. I can like if I did it from 913, like it will become tougher only. So I thought it will become easier to iterate it from right side. Okay, so I reversed the string and I added a 0 to the string, because what happens, like in the second example you can see there is in one, like after rounding up there is in one extra digit in the string. So to balance that up, I added a 0 to the string, to the first index, like this will be like 0999. What happens then is let us see. I made this 099. What will happen is after rounding up, I'll get 100. Like I don't have to like handle an extra case of getting 9 here or like that. So that to balance that, I added a 0 to the string. Okay, next this carry is for that carry part, like here if I add round it up till 9, okay, till this 9, so I'll get a carry of 1. So I have to carry that to previous index, so I have taken a variable of carry. So what happen if I have a carry, if the carry bit is on, like I have 1 carry, then what will happen if I have 9, then carry and the 9 will be added only, and I will get 10. After getting 10, what will happen is so I have to, like if I get 9, I have to ignore that, like, because like, I'll handle that below. If I get less than 9, like 8 here, and I haven't carry from the previous one, like if I round up till this 9, so I'll get 0, 8 0. I'll get a carry from the previous 9, and the carry will be get added to 8. So I will get 0, 9, and 0. And this carry is handling that part only. Okay, then I'm getting the integer value from the index of the string. Then if the if the value plus carry is greater than equal to 5, then this second rule applies. I apply the second rule, not second rule, sorry, first rule. The k minus 1 position is greater than equal to 5, then I have to add a carry to the previous, it's like it's आगे वाला index, no, इसका पहले वाला index, तो I have added 1 to the carry. समझ रहे हो ना, that like if I round it up the 8, what will happen? I'll get a carry of 1 to its previous index, that carry. Then if I round it up, then this index will become on 0. This value will become 0, because if I round up this 8, this becomes 0, this becomes 0. Okay. Otherwise the carry is 0. Then what I've done is I reverse back the whole string, because I reversed this previously, so I have to get back the strings again. So I reverse the strings and I have initialized an variable I equal to 0. What happens if s of equal to 0, like if the first index is still 0, like I have added the zeros to the string. If it is still 0, I am incrementing the string, because I don't have to output this 0. Like if I get something like this 070, I don't, like 040, I'm getting 040. I'm getting 040. Then this 0 is not changing now, but I don't have to output that 0 now. So I am incrementing I. Then a for loop, like what happens, this temp is the previous like string I have gotten, like this previous string, like the string in the on the input of the test cases, and then s is the modified string. I've modified the string here. So what happens till like you can see here, this is the given string and this is the modified string. So what happens, this 3 and 4 is not equal. This 0 and 0 is equal, like if I put 2, this 2 and 2 is equal, this 3 and 4 is not equal. Okay, I am outputting the string till there, and after that I have to output 0, all zeros now, because what happens ki, in the question it told ki to output 0 after after rounding up our index. So for that, what I am doing is I'm checking if temp I is not equal to s, like given index is not equal to the modified index. If it is not equal, then I have to output 0 from that index only. Then I outputted 0 from that index. Okay, this is some modified for loop and stuff. This question is based on only implementation. You can try to implement it. Okay, I guess it's fine. Do you have any questions? Okay, I guess I don't have any questions. Agraj will continue from here.
Hello, Dimple. Hello.
Okay, okay. Yes, yes. सुनाई दे रहा है.
Hello. Am I visible?
Yes,
Hello.
yes.
Am I visible?
It is visible.
Okay.
It is visible. It is visible.
Okay. So here now I'm going to explain. See. So in here there is an array of n integers. Firstly, Sasa has an array of integers. Basically, it is given that.
Wait.
Have,
Browser is not visible. Please sir. अच्छा आया ओके मेरा नेट से हाँ आया अभी लेट्स
okay. Is it visible now?
Yes, bhai.
Okay. So basically, it is given that Sasha has an array of n integers. He got board of I comma j, where I is less than j. He wrote down the minimum value of aij. Basically, he have made a new array out of that previous array that he said, and he has write the minimum of those the pairs, that all the pairs that he can have actually. Okay. Now, of course, if the previous array of, as previous array size is n, then he would get the number of digits is n into n minus 1 divided by 2. Now the next array that he have made, he have given it the name of b. Okay. Now what he have done is he has actually shuffled up the whole array b. Now we have to find that we have to find the previous array if it exists. Of course, if it will exist, because it is made from that array event. Now the question has some constraint of n is 10 power 3, of course, and the second line will have the array b, which of size n into n minus 1 divided by 2, the element b. Okay, so the first observations in this question is that uh, uh, the first observation is that of course for every b that will be in the test cases, and a will exist. That is the main observation. Now what actually, let me show you some. Okay, let take this test case, this one. Seven five 3 5. So now for this test case, it is of course of size probably n into n minus 1 divided by 2. Okay, it is of size 6. So we have to for my according to my approach, I have done that. Listen, I have actually first sorted the whole array. So now the array will become 3 3 3 again 5 5 and 7. Okay, now if I have seen that. Okay, let's see if I have array of 4 integers, for example, 4 integers. Okay, 4 integers. So now okay, if I have array of 4 integers, then the first element will be, for example, if a minimum of a1 comma a2. The next will be, of course, minimum of a1 comma a3. Then a1 comma a4. Again a2 comma a3, a2 comma a4, like this. So in this case, if I am seeing that, for example, okay. Now the first thing is that if I take the first element as my first number, for example, the smallest number here, 3. Now 3 will, if this is the smallest number in the whole array, of course, if it is the smallest number, it have to appear thrice. Listen, 3 will go to this, 3 with this, and 3 is this. Of course, 3 is the minimum element, and you have seen that 3 has appeared 3 times. So 3 is the minimum element of there. Now coming to the next element, 5. For example, let there be x1. This x will have to be minimum of this x will be minimum of this. So x will appear 2 times. So here the 5. Here it will be the 5. Now for the 7, of course, 7 will appear 1 time only. So I will initiate it with the maximum element that can be possible here. So that is my approach. Let me explain with you another example. Another example is 5 3 0 0 0, minus 2. Now, if we'll sort the array, the frequency will come like that: minus 2, minus 2, minus 2, minus 2, then 0, 0, 0, 0, 0, and then 3. Yes. So first, if I have 5, I will make 5 spaces: 1, 2, 3, 4, and 5. So if I have an element x, if this is the smallest x, it will be minimum of this, this, and this, and this, and it will appear back in the array. So see, if x is the minimum element, of course, with this pair, it will make 4 pair, and there will be the 4 smallest element. So here you see 2, 4 twos. So the first element will be our minus 2. Next, if this is some x, it will appear 3 times, of course. See, there are 3's. This 3. Okay, no. Yes, this is 3. So here will be 3. So next element will be 3. Next element 0. So okay, now see, if something here x, if there is something x, it will appear 2 times. Next 2 zeros, so here will be 2 zeros, zeros. Now if there is a 3, it will appear 1 time, so it will be 3. So the rest element will be maximum element. So this is the basically approach of me. So that I will short here the first 4 element will be same, of course, because we have promised that from A only, from array A, B is produced, right? So of course A will exist and A will exist. So the first 4 elements have to be same. So first n minus element, n minus 1 element have to be same. Next the n minus 2 element will be same. Next the n minus 3 element will be same. Next the n minus 4 element will be same. This is the approach. Okay. Now I will show you the code. So here I have taken the input. I have stored in the value of p. See, I have made the array of the size, because it is given here that the size of the array is n, but we have to take input of the array b. So here the vector v is the b, so I have to increase the n, initiate n is equal to n minus n divided by 2. Now I have short the array first. Now here the answer will exist. My index will basically go from 0. So first I have to jump n minus 1 stages. Next, first I have to now jump. This number is basically the jump of the index. So basically, if I am at 0 index, so next time I will jump to index 4, next 3, next plus 3, like that. So index is plus is equal to none. Then again I have to decrease this thing. This is first n minus 1, right? And lastly, I have to push back the answer, the maximum value that I can make. Of course, this will not be included in this. Then I have to print this. Okay. So, any doubts? I guess there is no doubts. So let's move to the next question. Next question is strong vertices. Okay. So there is given 2 arrays, A and B, both of length 10. Okay. Elements of both arrays indexed from 1 to n. Okay. You are constructing a directed graph where edges from U to V, U is not equal to V, exist. If A of U minus A of V is greater than or equal to B of U minus B of U. Okay. Here is given that a vertex B is called strong if there is exist a path from V to all other vertices. A path in a directed graph is a chain of several vertices connected by edge, such that moving from U along with the directions, the edges, the U can be reached. Your task is to find all strong vertices. For example, you are given that A is equal to 3, 1, 2, 4 and B is equal to 4, 3, 2, 1. So the graph will look like this. Okay, there is the input. First the A is given, the B, and this. Okay. And lastly, we have to print the vertices that are strong, of course, in the ascending order. Now, okay. Am I visible? Okay, the first thing is that if A some vertices A. Let's see. Okay, for some vertex indexes, for that I, and for some vertex indexes J. For both the value, some A of I will be given, and for this B of I will be given. This A of I will be given, and for this B of I will be given. B of J, sorry. Now it is said that the vertices I and J will be connected by directed graph if A of I minus A of J is greater than or equal to B of I minus B of J. Now this is an inequality equation, right? So we can move this B to this side. So it will become B of I, and from I will move this to this so that the sign will change, and from Aij I move this. So this will become, the inequality will become A of J minus B of J. So now one can have the question why I have done this approach. I have done this approach basically so that I can separate the entities differently. So this, now you see, this is totally the ith side, completely dependent on the ith value, A of I and B of I. This is j set. Okay. Now if this condition existed, then only there is an I and J are connected. Okay. So what I can do is, for every vertex indexes, till n, I can actually have a constant value that is given, that is A of 1 minus B of 1, comma A of 2, comma B of 2, A of 3 minus B of 3, like this. A of n minus B of n. Now here is said that some vertices this and this are connected only if this is greater than this, of course. For example, this. So what I can do is, I can have some indices with this. Let's call it an x1, x2, x3, and x3. So if I sort this, if I can, if this is one, right? 1, 2, 3, and 4. If I can make this pair short based on the value of xi, then we'll get something value like some value x, some random value of xi, some xi, xi. So here this value will be the largest. This value will be the largest. So if for this value multiple value will exist, then this will be connected to each and every group, because we have seen that this this will connected to this only if this is greater than this, right? So the maximum value with this value, with x, the maximum value of x, the vertices with the maximum value of x will be connected to the every other vertices. So if multiple value with same max value existed, then it will be connected. Let me tell you the example, you can make it better understand. Click on that. It's 5, 1, 2, 4, 1, 2, 5, 2, 3, 3, 1. Okay. Now let's see. What is 1 minus 5? This is minus 4. This is 0. This is 1. This is minus 2. This is minus 2. This is 1. So if this is index 1, this is index 2, this is index 3, this is index 4, and this is index 5. So if I sort this array, minus 4, minus 2, 0, 1, and 1, you see that the one with the value of maximum, here it will be 3 and 5. Of course, this is 3 and 5. Right? This will be connected to every other vertex. Right? This will be connected to every other vertex. So we have to print 3 and 5. That will be next. Okay, let me see. Let me go to the code. Okay. Here I have taken that. I have taken the input of the both vector. The both vector will be the size. Okay. Now this is the vector where I will store the value of xi, right? Xi. Then I push back this value. Then I will find out the maximum element among all the value that I pushed. Of course, it can be multiple. Later, I will have to introduce an answer to print. Then I will iterate from the whole array in the VP. Okay. So if the value is equal to max, then we have to push this answer, push these indices in the answer. Of course, the index will be index plus 1. Okay. Now lastly, we have to print this. Okay. Any doubts? Any doubts? Okay. I guess we have to move to the next question. The next question is, if I given n points with the integer coordinates x1 to xn, which lie on the number line. Okay. For some integer s, we construct segments s, x1, s, x2, s, x. Note that if x1 is less than s, then the segment will look like this. So of course, he is saying that the smallest index will be first, right? So, smallest index will be first and the larger will be next. Okay. We define the power of a point P as the number of segments that intersect the point with coordinate P, defined as. So my task is to commute for all integer, all point from 1 to 10.9 fp for each s. See, the s is here variable for all constant. Okay, for each s here represents all the xi, x2 to n. The sum, okay, the sums of these are integers from a type. This line is actually not needed because it cannot exceed again. For example, here the example is wrong. If the initial coordinate are 1 to 5, 7, if we choose s is equal to 5, then the segment will look like something 1 to 5, 2 to 5, 5 to 5, 7, 5 to 7, 1 to 5. And the powers of the point will be this. F of 1, 2, 3, 4, 5, 6, 7. Okay. Now let me go through this with an example. Let me explain this. Okay. Given that, for example, if the array is like this, the array is like this. So if I have taken, let the s be 5. So what will the segment look like? The first segment will be 1 to 5. The next segment will be 2 to 5. Third segment will be 5 to 5. See here, it will not be 75, because it will lead to us 5 to 7 because the question stated already. Okay, so 5 to 7. I want to. Now, if I write all the code, all the 4, 5, 6, 7, 8, of course. Okay. Now, the first segment here is from 1 to 5. Right? Yes. From 1 to 5. The next segment is from 2 to 5. Third segment is from 5 to 5. Fourth segment is from 5 to 7. And of course, the last segment is from 1 to 5. Yes. So, how many actually we have to find this, that how many segments actually cover this integer point 1. You see that in 1, 2 segments are occupying 2. So, for 1, it will be 2. Okay. Now, for 2, see that it is occupied by 3 ranges, okay, 3 segments. So, it will be 3. See here, it is 3. Okay, for 3, it is of course again 3. For 3, it is again 3. So 4, yes, 4, of course, again. 5, listen, here for 5, 1, 2, 3, 4. Okay, I'm sorry, for 4, it will be 4, 3. For 5, it will be 4. For 6, okay, for 5, 1, 2, 3. For 5, it will be 5, sorry. Okay. For 6, it will be 1. For 7, it will be what it is told that we have to build an answer. For example, for s is equal to 5, the answer will be the sum of this, the sum of the whole this thing. Okay. So for 5, so sum will be for this thing, that is 2 plus 3 plus 3 plus 3, this thing, plus 1 plus 1 like this. Of course that will be 18. Now I've understand the question. Now for the approach. For the approach. Okay, for the approach. For the approach, let's see this one, 10, 100, and actually 1 to 5, 7. Okay, for approach, let's understand the approach. 2, 5, 7. Okay, if I attach an index with everyone, this will be index 2, this is index 3, this is index 4, this is index 4, and this is index 5. So actually for the index part is because we have to sort the array. So we have to basically pair. In this pair, the first thing will be the value, the val part, and the last part will be the index part. So I have to make a vector of pair, like pair of something, the pair of something, and then sort it. I will tell you the reason why I will sort it. See, I have sorted. So after sorting, we also know that index. Okay, for example, this is 1, this index is 5, this index is 2, this index is 5, and this index is 7. Okay. For example, this is 2, this is 3, and this is 4. Now see, if I have taken this in this fit 2, so how will be the segments look like? It will be the first segment will look like 1 to 2, next segment will look like 1 to 2, next segment will look like 2 to 5, sorry, 2 to 2, 2 to 5, and 2 to 7. So the answer lies between the value that it is actually accommodating in and also, because this it will start from 1 to 2, right? So it will increase the value of this one with 1 and this 2 with this. So for this value, it will increase the value 2 minus 1 plus 1 of the values of the answer, of course. This also 2 minus 1 plus 1. This 2 minus 2 plus 1. This 5 minus 2 plus 1. This is 7 minus 2 plus 1. So the answer is this, the summation of all this. So if I actually partition the array for 2, for example, partition it, like this one is a partition and this one is a partition. Okay. So for this partition, let's see what I am doing. This is 2, right? Minus 1 plus 1. This one will be constant. Okay. 2 minus 1 plus 1. So what I am actually doing is I am actually, if I sum these things, right? If there are multiple things, if I sum this thing, what will become? This is actually the value of the index that we are currently in, multiplied by the past things, the number of past things that I have written. Here it is 2, okay, minus the past sum, means the sum up to last index, not that index, last index. Okay, here it is 2, of course, and we have to finally plus this thing, the number of things that are actually passed through, that is here 2. This is of the left part, and for the right part, of course, let's see. For the right part, it is 2 minus 2, 2 minus 2 plus 1, 5 minus 2 plus 1, and 7 minus 2 plus 1. Okay, so 2 plus 5 plus 7 is the right sum. See, 2 plus 5 plus 7 is the right sum. So I can completely state it here, right? This is the right sum. So let's say it right sum. Right sum. Okay, right sum minus this index v of I. How many times? The number of times, that is this 3 times. Okay, this is 3 times. Yes, 3 times. Now I have to plus it with how many times? The number of elements in the right side is 3 times. So that we can do it O of 1, right? Yes, we can do it in O of 1. So here, if we iterate through here, and we know the sum of this part and this part, we can directly calculate in O of 1 the answer of that part. Answer of that part, that index. For answer of 2 index, of course the answer will be in 2 index, right? The 2 index. The answer of 2. The answer of 2 index. I will go to the code. Yes. I have taken input first, then I have taken the vector of pair. Okay. And the sum is equal to 0. This sum is actually I am doing the sum so that the whole, I am actually taking the whole part of the sum. Now this is only the value of the first value, and that the index is. I actually shortened this. I've already discussed that why I have shortened this, because I have to actually partition it with the value of left and the value of right, so that I can already derive that from derive this formula, right? Yes. So for the left part, what to do is the number of times the past things are there, means the number of the index in number of items till that index, right? P of I dot first multiplied by minus the prefix sum of that, means up to that sum, up to that index, what is the sum is there, plus number of rows for the I one part. Okay, for the right, it is to the sum minus prefix. Okay, so we'll find the right part. We'll find the sum of the right part, right? This minus this number of times with this number of values, and the number of times this have to be multiplied in this right part, for the right part, plus number of elements in the right. Of course, in the answer, instead of vi dot second, this is the index that I have stored in equal to left plus. Of course, after leaving this iteration, I have to uh, make the prefix sum again plus of this. Then I have to print the answer. This is actually the answer of observation. Okay. Okay. Any questions about this question? Any? Yes.
Hello, Dimple. Hello. Am I audible?
Yeah.
Yes, yes.
You're audible.
Okay. Is my screen visible? Can anyone?
Yes, yes.
Yes.
Okay.
Yes. It is.
Let's discuss question number F. So in question number F, we are given an array of length n, and we have to answer Q queries given X and Y. So basically, we have to find the total number of pairs such that AI plus AJ is equal to X and AI into AJ is equal to Y. For example, in this array, we are given 1, 3, 2, and asking for X equal to 3 and Y equal to 2. The answer is 1.
because as it is given here, when I is equal to 1 and j is equal to 2, it fails because 1 plus 3 is equal to 4, not 3, and 1 into 3 is 3, not 2. If it's I equal to 1 and j equal to 3, then it satisfies both the condition. And if I is equal to 2 and j equal to 3, fails because 3 plus 2 equal to 5, not 3, and 3 into 2 is 6, not 2. So there are two conditions basically. One, it is given at I less than j, but it doesn't really matter because both plus and multiply are commutative functions. So it doesn't really matter that aj plus ai is equal to ai plus aj. So it doesn't matter. And ai into aj is equal to aj into ai. So it doesn't really matter about this condition. So what we need is to find the total number of possibilities, total number of pairs, that is. So my initial approach is using maths. Let's consider like at first ai as a and aj as b, arbitrary values. And we are given two equations, a plus b is equal to x and ab is equal to y. So we can solve this using quadratic equations. Okay, let's take b is equal to y by a, and thus a plus y by a is equal to x. And we can similarly see that for b also the equation is similar only, y by b is equal to x. Since they both are similar, so we can just find value for one and get the value for the other. It will be the same only, same equations. So this is a square plus y is equal to xa, thus a square minus xa plus y is equal to 0. So as it is a quadratic equation, there are two solutions, let's say alpha and beta. One alpha is so let's solve for alpha and beta using the quadratic formula. So it will be like minus b is like minus x plus minus b square x square minus 4y divided by 2. So that is x plus minus x square minus 4y divided by 2. So alpha can be ai and beta can be aj. So we will solve for basically ai. Now as we can see, like ai is equal to x plus minus x square minus 4y plus 2. So there are some conditions. As we know, ai is an integer, thus this must be integer too. X plus minus root over x square minus 4y whole divided by 2. So for this to be an integer, there are like two conditions. One is that this x square minus 4y must be a perfect square. Let's write it, x square minus 4y must be a perfect square, and x plus minus root over x square minus 4y modulo 2 must be equal to 0. So these are the two conditions that we must take care of. After we take care of this, then we will get ai, and one will be like wait, let's keep the conditions. So alpha can be, we can take it as like x plus root over x square minus 4y divided by 2, and beta can be x minus root over x square minus 4y divided by 2. So these are our two values, and we can store our values of the array in a map just to check like how many such values are there. So let's move on to the code and like see what I've done. So at first what we are doing is we are storing all the values in a map, count of the values, frequency basically, and then taking the query input. Then at first, as I told, there are two conditions. One is x square minus 4y must be a perfect square. So how am I checking it? Like at first I am calculating this x square minus 4y, that z. It can be so that it can get like negative, which is not possible. In that case, the determinant will be imaginary, which we don't want. And then we can thus we will simply say that number of such queries will be like 0. The second is like it must be a perfect square. For the perfect square, we are finding the square root of the determinant, and then we are simply checking by multiplying if it's a perfect square or not. If it is not a perfect square, then we are simply returning like